Hello, everyone, and welcome to the Geek Narrator Podcast. I am your host, Kaivalya Apte, and as usual, I am back with another very interesting episode. Today, we are going to talk about observability engineering, and it's becoming more and more popular and more important for software engineers who are working on distributed systems, on complex architectures, and things go wrong every time, every now and then. And you need a good way to understand what's exactly going wrong because that is going to help you to mitigate the issues as quickly as possible. And that's observability is all about. And I'm also learning. With this, I want to welcome our guest for today, Liz Fong-Jones. And Liz has an amazing experience in the reliability and observability space. So welcome, Liz. Thanks a lot for joining me today. And let's start with a little bit of introduction about yourself, about your experience, and what you're doing currently.
Yeah, I come from a very long background in the SRE space. I've been working as one flavor of systems administrator, site reliability engineer, platform engineer, whatever you want to call it these days. So as far as what Honeycomb does, Honeycomb is one of the companies that really popularized the idea of observability and was one of the kind of earlier implementations of genuine, true observability rather than just renaming logs and metrics. And what I've discovered in that evolution over my 20 years of working in this particular field was that I started off being just a systems administrator or site reliability engineer working on one service. Then I started managing a team of about a dozen people. And I realized that there was so much beyond just those dozen people that I wanted to make not just the lives of the dozen people on my team super great. I wanted to make the lives of everyone working in our industry super great by helping spread knowledge, helping make sure that everyone was adopting the best practices rather than having these pockets where people were doing really great things and no one was finding out about how do we actually share the wisdom, how do we actually get teams to adopt better methodologies, and yes, tooling sometimes. So towards the end of my career at Google in 2018, 2019, I decided that I wanted to transition away from being a SRE advocate in general for the SRE community and focus on one particular area that I've found to be a challenge for a lot of teams. What do you do? I loved your intro, by the way, right? What do you do when stuff hits the fan, right? How do you make sure that you are able to debug your services? And Honeycomb was really aligned with what I thought that I wanted to do as far as transforming the industry, transferring the way that we run software, the way that we think about how we manage the complexity of software. I went from being an SRE at Google to being a developer advocate for SRE at Google to being a developer advocate for observability at Honeycomb, helping educate the industry about how they might better improve their observability practices, how observability differs from what people had done before, and so on. And in about a year and a half ago, October of 2022, I was promoted to Field CTO, which basically means a change to the kinds of people that I interact with and the level of engagement that I deliver, but it's still very much in the mission of how do we push the forefront of what observability is. So previously, when I was working as a developer advocate, the kind of mission and the goal was to work as broadly as possible to get bottoms-up support for observability, to educate practitioners in the industry. As a field CTO, I worked a lot more with our largest customers, our largest prospects, with executives at those companies. Because when you have 20 years of experience, it really lends itself well to be able to not just interact with people who are practitioners on the ground, but also to help translate things to executives as far as what business outcomes they can achieve, how observability can transform their businesses for the better, and more generally, how we can help them achieve the business outcomes that they're looking for.
Awesome. That's very cool. And so typically I like to start very basic because I don't want to assume that our viewers know all these terms, right? As you mentioned, observability, logging, metrics, monitoring, there are so many things. And I believe even I misunderstood this when I initially started understanding what is observability. I started as an SID engineer. So I also confused between monitoring and observability. So let's clear out these terms before we get started, right? What do
Yeah,
we
it's always a
exactly?
perennial struggle, right? It's the same thing as defining what is DevOps. How
Yeah,
does DevOps differ from being a sysadmin, right? There are 1,000 different definitions, and I'd argue only some of them are
yeah,
correct.
yeah, absolutely. When I was looking for definitions on observability, right, I found one thing in common. Like everyone is talking about, if you want your system to be observable, you should be able to understand the internal state by just looking at the external state. Now, I want to go deeper and understand what do we mean by these internal and external states. And from there, let's get the understanding of the differences between these terminologies.
Yes, so the definition that you just cited is the control theory definition, which is where actually the word observability comes from. As the in academic literature, it's viewed as the dual of controllability. Controllability is how well you can manipulate the system. Observability is how well you can understand the system based off of the telemetry data that it's producing. Remember, this is all control theory. This is all kind of abstract mechanical systems or otherwise not necessarily related to computer systems. So the way that I think it was originally in 2014, 2015, something like that, the Twitter team discussed this idea that they were pontificating about how to better understand their systems. They used the word observability because they felt that it was appropriate for the challenges that they were facing at the time. For how do we understand a system without perturbing it, right? How do we understand this massive microservices architecture, one of the first microservices architectures, right? Like, how do they make sense of it? So that's where observability first was applied in the context of software observability rather than control systems observability. It turns out to be a little bit of an unwieldy definition when you apply it to software because it comes from control theory, and control theory is very a little bit abstract, a little bit too far up the stack compared to how software practitioners think about their challenges day to day. So when Honeycomb came along, when Honeycomb's co-founders popularized the word observability, we started trying to figure out how can we digest things? How can we make it more accessible and understandable to a practitioner, right? Like instead of talking about understanding the internal state from the signals, right? Like instead that became for us talking about telemetry data, right? Like what's the output that you're getting from your systems? And when we talk about internal state, right, like we talk about what is your code running, what is your code doing? And the traditional approach that people previously would do for it that doesn't meet the requirements in our view is they would just push new code. They would push new code that has printf got here, printf debug, here's the value of the variable. That doesn't scale in any modern system because you can't reach onto the machine and touch it. Similarly, like attaching a debugger, you're probably not going to do that to a production process that's running at full production volume, right? So we started translating the terminology into something that was a little bit more accessible to people who are ordinary software developers. Relating to them, you don't want to have to push new code to production. You want to be able to understand problems using the existing data. And I think that's a little bit more workable of a solution. And then the other kind of thing that we've had to differentiate is people said, oh, we have metrics. We can tell you exactly how many HTTP 200s and 500s there are, right? And great, but can you explain why those HTTP 500s are coming up? And it turns out they couldn't, right? Because that is a new question, not a question that you thought to add a metric for, right? So we've had to refine the definition and explain a little bit as we go, because I think you're right. If you start from control theory, you wind up at too high of a level. It's not really applicable to the challenges of practitioners.
Absolutely. And the core challenge I've seen and I've also faced that, okay, you understand what is observability at a high level, right? But then you end up talking about metrics and monitoring. So
Yes.
am I right if I say, so imagine your system has all these metrics and monitoring, but gluing them together and making sense out of those metrics and monitoring and logging and traces to understand your system as a whole, that's more of observability, right? Or there is something you want to add more?
I think that monitoring has its place and observability has its place. Monitoring is helpful for telling you when you've breached a known condition about your system, right? Like the number of HTTP 500s is too high, right?
Yeah.
That is a good thing to monitor for. I'm not saying you shouldn't monitor for that. Of course you should monitor for that.
Yeah.
But I think observability's role is to shorten that feedback loop of being able to restore your system to a working state that you understand, right? Of being able to understand it and fix it.
Yeah.
So when you have too many HTTP 500s, you may not necessarily have the data in your metrics. You may need to, as you say, correlate logs and maybe internal system metrics. But wouldn't it be better if you just were able to trace the failing requests and figure out what was going on, right? Yeah. So in that way, observability itself is not, like, the concept of observability is agnostic as to how you implement it. And this is the other confusion we frequently encounter is people are just like, observability, I have my logs, I have my metrics, I have my traces. Do I have observability yet? And the answer is, can you actually understand your system? If you can't, then you don't have observability, right? Like, it's not Pokemon. You're not collecting all the signals for the sake of it. You're trying to achieve the outcome of being able to understand your service. So I think in that context, when we talk about monitoring is about known unknowns. Observability is about unknown unknowns and asking new questions and being able to reconcile your mental model of what's going on versus what the system is actually doing.
That makes sense. And I believe it's not like a state. It's a continuous process, right? So it's not like a Boolean flag.
It is a continuous process, and it is a socio-technical process, right? Like, it's not just about the data signals, it's about the people's ability to use them, right? And I love what you said about a continuous process, because you wouldn't say, my code is 100% testable, I'm done, right? There's always work that's needed in order to keep your system testable. And there's always work needed to keep your system observable. New people will onboard, you'll add new surface area, right? How do you make sure that every line of code that you're adding, or at least every subsystem you're adding, has the appropriate observability?
Yeah, that makes sense. Let's talk about a little bit about the misconceptions, right? In your experience, what are the top misconceptions that people have about observability?
I think the main one is just spurred by people who are similar to, do you have DevOps yet? We renamed our sysadmins, right? I think the main misconception is that observability and monitoring are synonymous, right? They are not, and they differ in what you're trying to measure and how and why. The second misconception is about the conflation of telemetry data types with the observability outcomes they may or may not help you achieve, where vendors are selling, here's observability in a box, and you look inside and it's just a very expensive bunch of custom metrics and logs, right?
Yeah.
So people renaming their existing products. And then I think the final misconception about observability is what we said earlier, right? That it is just a thing that you do or don't have, that your system has, and that it has no relation to the people, when in fact, observability is more about what's the outcome that we're trying to achieve. Are we actually achieving that outcome? Are we actually able to understand what our system is doing?
Do you mean that so let's assume you are using some sort of observability framework or some tooling around it. You have everything there, but your people are not trained on how to use those tools, or they don't have knowledge about that. So basically observability is missing, right? Because they cannot use the available tooling.
Yes, closing the feedback loop is a major problem. And that manifests in two ways in my experience. First of all, it may be the case that the data is flowing, but that it is stored in a format that is too slow or too expensive to query, such that people are not actually querying it. Sure, in theory, you would have perfect observability if you wrote every single trace span and every single log to AWS S3. Good luck retrieving it out of there. It'll take a while.
Yeah.
You can do it with AWS Athena, but I'd argue that's not observability for the purposes of rapid fire debugging when your system is down. And the second thing that's happened is there are these people who have been the longest tenured on their team, who have been around a while, to understand how to manipulate whatever tooling. And if you have one wizard on your team who knows how to do it and everyone else is stuck, congratulations, you now have a single human point of failure. What happens if that person goes on vacation? What happens if that person retires? I think it's incumbent upon us to help everyone achieve observability and not just the most senior or expert debugger on the team.
That does make sense. I'm also curious to understand like why observability is taking so much, let's say, fame or popularity nowadays. Is it because, so I understand that the expectations from the users of your system has also changed, but from the technical standpoint, is it that now it's becoming more and more possible to do all these real time analysis and provide developers this tooling?
I think it's the combination of multiple factors have led us up to this moment. I think the adoption of microservice architectures have meant that traditional APM no longer works because APM is something that you apply to a single running binary and not when it's talking to many different services. So I think that's led to the repopularization of tracing as a data signal. And this is why you start seeing tracing being adopted more and more to try to achieve observability. I think you're right that there is also the angle of systems are becoming more and more business critical. It's more and more important to be able to resolve issues. And especially this tends to happen in multi-tenant situations. The kind of earliest practitioners of observability were those companies that were B2B and SaaS, because they know every bit of traffic that comes through their systems is unique to the customer. And also that customer cares very much about the success of it. It's not just undifferentiated ads page loads. I think the third factor that's led to observability as a phenomenon is it relates to my point about APM and kind of the spread of microservices, but it's a little bit more subtle than that. And it relates to system complexity. We are making our systems so complex these days that the only way to understand them is by being able to understand unknown unknowns and things that we didn't predict, rather than just saying, okay, I've slapped monitors on it, I've monitored for things I knew might break. Now there are enough things floating around that are unknown unknowns that we need to be able to understand them. Otherwise, we're going to have rubbish availability.
That's so true. And we software engineers see that every day. There are so many burning issues. You get alerts, you get paged, but you're not sure exactly what is wrong. And there are something
right.
is just
and the thing is that if you knew what was going to break in advance, you would not have written the bug in the first place, right? By definition, that means that anything that breaks in a modern production system that is appropriately tested is by definition going to be something unforeseen and perhaps unforeseeable.
Yeah. And not everything is in our control anyway, right? Like we are not writing each and every piece of code that we are going to use. So we use so many third-party libraries, so many third-party services. We are on cloud, machines going down, there's hardware, there's network, so many things can go wrong. So yeah, it's becoming more and more popular. Before we dive deep into more technicalities, let's also talk about the challenges that people typically face when they start on this journey of observability. That hey, you know what, we have this system and it's pretty good. We have found the product market fit. Users are using it and we are generating some revenue. But we are also facing some outages, and our customers and users are complaining that, you know what, it's taking a long time for you to fix any issues. So please do something about it. So what are the challenges that people often face when they are onboarding on this journey?
I think the difficulty is, as you're saying, that if people don't bake in observability-driven development from the start, then you're retrofitting things on after the fact, right? We've encountered this as well with the DevOps journey and architecting for reliability, architecting CI/CD, right? It's a lot harder to change the tires when the vehicle is already moving, but yet that's what you have to do. And the other challenge there is people are often like, oh, we're too busy, we can't stop to add observability, we're firefighting. And it's observability will help you firefight more effectively. Like, how do we make the argument to you to convince you that you really need to stop what you're doing, do things, implement, maybe not everything comprehensively with manual instrumentation, but at least add a little bit of telemetry, start gathering the right signals so that you can debug things better going forward.
Yeah. And there's definitely cost attached to it, right? Because observability is not for free, right? There's a lot of cost involved. And
Observability is not for free, but neither is developer time, neither is loss of user trust, right? I think that's, as you're saying, right, like you actually proposed earlier that part of the rise of observability was that it became economical to process the data. I do think that's true,
Yeah.
right? I think that what we're seeing in the ecosystem is a convergence around the idea of columnar storage databases as the kind of primary way to store this data on unknown unknowns, to store structured event or tracing type data, such that there are I could throw a baseball into Y Combinator and hit a company that's doing ClickHouse and implementing observability using ClickHouse, right? I think that's the reason why you're seeing so much commercial interest, is because the technology for processing this data at large scale has become mature and economical enough that people are willing to consider doing it. And also the cost of not doing it has risen substantially.
Makes sense. So is the recommendation that for any startup, if you're starting, try to inject or have observability practices right from the beginning instead of like an afterthought?
Yes, that's exactly correct. That adding metrics and time series is not enough. That it is much better for you if you at least do structured logging, if not full-on distributed tracing from the beginning, rather than trying to retrofit it on afterwards. That being said, we've also gotten really good at figuring out how to retrofit on data after the fact, especially in languages that support monkey patching or runtime injection. So we can talk about that in the kind of nuts and bolts section. But yeah, so we're in this kind of interesting moment where in 2017, when Honeycomb came out of stealth, it was very much a, what is observability? What are you even on about? And then suddenly 2020, 2021, everyone is using the word observability, but not necessarily in the way that we meant it.
True. Let's go into the technicalities. So you mentioned a bit about structured logging and events and traces and also open telemetry. What does it all mean?
Yes. So as I was saying earlier, you need to have telemetry data in order to be able to achieve observability. And then you need to have somewhere to put the data and to analyze it and to make it accessible to the developers on the team so that they can achieve those business outcomes. So what OpenTelemetry aims to do is to commoditize and standardize the data production piece so that people can focus on doing the data analysis if they want to be a data analysis company, and so that end users don't have to think about, what if I want to change vendors? What if something comes up? Do I feel comfortable baking this into my code and leaving it there for 5 years or 10 years? So OpenTelemetry is an open standard under the Cloud Native Computing Foundation that aims to make a collection of a variety of different signal types, including traces, including logging, including metrics, and as well as some new emerging signals. And to do it in a vendor neutral fashion such that you can feel comfortable including this in your code base, to centralize everyone's development of these agents so that you no longer have vendor proprietary agents that are hooking into binaries, and to produce the data in a standard format such that you could even, send it to multiple different destinations at the same time, to really improve consumer choice and to allow for people to innovate at what they do best.
Okay.
Concretely, what OpenTelemetry does for an end user is you include the relevant libraries either via manual inclusion or via attaching an agent, and it hooks in and discovers what are your HTTP calls, both incoming and outgoing, what are your database calls, what are some of the attributes of those, what's the prepared SQL statement you're executing, what is the user agent, what's the path that's being accessed, and so forth. And then it can send that in the OpenTelemetry protobuf format to any supporting backend where it can be then analyzed.
Yeah, sounds good. Having observability in place is one thing, so you can use existing solutions and So that is another thing I wanted to ask you, but I'll ask at the end. The ultimate goal is to make your systems more reliable, right? Like, okay, you are facing incidents, you are able to figure
Yes.
out issues quickly, but how to take that feedback and feed that back into the system and the practices that you follow. So I guess the ultimate goal is reliability. And when it comes to reliability, we talk a lot about these terms like service level objectives and indicators, and we have agreements based on those objectives. So let's talk about those, like service level objectives and SLIs.
Yes, absolutely. Although I would actually quibble and say reliability is not necessarily in and of itself an end goal, right? I think it's more about preserving user trust. Reliability is one aspect in which we do that.
Yeah.
And I think it's also about enabling developers to feel confident, right? It's enabling people to feel that they can ship changes to production, right? And I think, so now to lead into your question about SLOs, right? Like when we define a service level objective, it's about defining what is the appropriate level of reliability that preserves our customers' trust while enabling us to innovate at the pace that we need to, right? If reliability were our only concern, right, you might have the lunar lander or the space shuttle code, right? Like where people don't touch it by and large, right? Or they have a year-long change approval process because it has to be pristine. It has to be not changed. Every change has to be completely meticulously vetted, right? Like that's not the standard that a majority of businesses should be aiming for. So I think that's what an SLO enables us to do, is to agree on what level of reliability is appropriate for our product. How do we treat reliability as a product feature? How do we measure it and govern our systems in order to achieve that level of reliability and not necessarily go overboard on it?
That makes a lot of sense. And thanks for adding that perspective, because I was mainly thinking from the technical perspective, but at the end, it's about the user. If you don't have any
Yes, it's about the
user,
business outcome. Yes.
exactly, you're not making any revenue, so you cannot do anything about it. That makes sense. And let's take an example here. Let's say I'm a small, let's say an e-commerce company, and I want to have and set up these SLOs and around my services. And like, how do I create a process and mental model to think about having those SLOs, and where should I start exactly?
Yes. So this is actually some of the material that I got the chance to work on in the last 2 or 3 years of my time at Google. Was the various site reliability workbook materials, all of the training courses around service level objectives. Highly encourage people to look at it if they want more than a 5-minute teaser. But in essence, you want to start with the idea of the critical user journey, right? What are the most common workflows that people are trying to do with your product? So in the case of an e-commerce site, that is actually one of the examples that is nicely covered by the materials in the SRE workbook, right? So you have does the homepage load at all? Does it load quickly enough? If people can't load the homepage, you have a serious problem. People might churn. And then you might also say, searching for products is a critical user journey. Checking out is a critical user journey, right? Like that there are, you rate them in order of criticality to the business and also in terms of how frequently they're done. So if people can't even load the homepage, your business is losing money. If people cannot log in and check their order status, that's not necessarily fatal. I might not necessarily start by instrumenting that, but that core loop of load the homepage, search for an item, buy the item, you have to be able to do that. If you can't do that, you don't have an e-commerce site. Think about enumerating the critical user journeys, thinking about how might you measure their success, what level of success is appropriate, and how slow is too slow, right? Sure, abstractly, if I can load the homepage in 30 seconds, technically speaking, the homepage is loading. Your users have already clicked away by 1500 milliseconds.
Yeah, that does make sense. And when we talk about these critical user journeys, I can't help but think about the UI interaction or the front end of
Yes.
it, because we are also taking this e-commerce example, add to product.
Yes.
And add to cart and search for products. But let's take examples of different types of services that you may have, right? Not all products are customer facing, like direct customer
Correct.
facing. Some are just API companies. And in a large e-commerce company, for example, there are multiple teams working on different types of products, right? So let's take examples. So first one is, let's say, who are directly maintaining services that are behind the user interface. Then there are services who are purely backend services, but of course they are the core, the backbone of everything, like authorization, authentication,
Yes.
all those kind of services. And then there are backend jobs that also have some critical things to do. How should I go about and think when it comes to SLOs for these types of different types of services and products?
This is where SLOs can really shine, is not just the top level, what's the consumer experience, but to encapsulate a contract on performance between different teams. That you might have your database team. Your database team might be afraid of doing database maintenances, and you might be falling behind on security updates, right? Like, how do you negotiate that contract to say our database service is allowed to go down for up to 5 minutes per month? Right? So you have to communicate, this is our SLO. This is what this SLO, right? Like, this is what we're intending to do with the error budget, with the change window, right? We are intending to be able to keep your system security patched and so forth with that error budget. And then it communicates expectations to upstream teams of, if your service depends upon having less than 5 minutes per month of downtime, you need to use multiple databases, you need to add a cache. Like, you have to do something in order to mitigate for the fact that SLO is less stringent than your own more stringent SLO, right? So you don't necessarily want to have a hard dependency upon a service that has less reliability than your own SLO, right? So it helps you establish this hierarchy starting from the user going all the way down to the backend service of, what are the contracts between the different teams and what mitigations are in place in case those contracts cause an inversion of the reliability hierarchy. Because if you're aiming for your front page to be four nines available, that means that you probably don't want to depend upon 5 different other 4.9 services with a hard dependency, because then those in aggregate will add up to way more downtime. But you cannot mandate all of your dependencies be 9. So what do you do? And that answer then revolves around kind of mitigations, partial outages, degradation without full outage, right? Maybe if you're having the recommendation service be a pain on the front page, maybe you don't refuse to load the entire homepage if the recommendation service is out, right? So this helps us have productive architectural reliability conversations when we know what are our critical user journeys, what are our services capable of, and how do we mitigate.
Yeah, that does make sense. But let's assume the e-commerce company is trying to bring all those SLOs in place and trying to bring the representatives of the different teams and bring them up to same page. How many SLOs should you have? So if I think about it, like everything I'm doing, everything I'm serving is critical, right? So should I just have one SLO for each, let's say, HTTP endpoint or resource, or at that granularity level, or should I have it more focused on one user journey, but that ends up hitting one service? So what should be the granularity, and how should I go about thinking when it comes to setting up those SLOs?
Yeah, the rough guideline is 3 to 5 SLOs per service or per major chunk of functionality. Our recommendation in general is to combine your latency and your availability SLOs, and to say, if it's slower than 2000 milliseconds, it just counts as down, right? So count fast failures and slow successes both as failures. And that kind of helps reduce your sprawl of SLOs to say, these are our most critical kinds of journeys. The other thing is, you might want to lump together viewing products and viewing the homepage and anything that you expect to be a straight up lookup very quick, right? So you can start bucketing things and say, this is our quick response read only bucket. And then you have things that mutate state, like checking out, like updating shipping address, like updating user profile, right? So that kind of helps you avoid having 100 different SLOs, right? Like by saying we have these categories, we're going to group similar endpoints together. And then I think when you get further down the stack, right, like I think your database team might have 1 or 2 SLOs, right? Like you might just have an SLO for this is our standard for how we make available a standard MySQL interface. So it's this balance of not going overboard and measuring the right things. But the key thing I want to communicate, though, is you do not have to go overboard from the start. Just measure something, even if it is 100% of your incoming HTTP requests. If you're not measuring at all what your scorecard is, you have no idea what's going on, right? You could have 0.1% of users that are seeing latencies of 30 seconds and you would never know, right? Like, so start somewhere, then start breaking it up rather than saying, I have to exhaustively catalog every single critical user journey and like I have to create 100 different SLOs and I have to measure it from the front end and from my user's mobile device. Just start somewhere. Like start with your server logs if that's what you have accessible to you. Start by grouping everything together into one SLO. You can always split it out later.
That makes sense. And when it comes to, so let's say search page, that team has one SLO, but the search depends on few other services.
Yes.
And each one of those will also have some SLOs. And of course, it has to be
its own internal SLO, yes.
Exactly. And it has to be tighter than the outer SLO because otherwise it won't work, right?
It has to be tighter, or you have to have a mitigation like caching or retries or potentially just dropping that endpoint and omitting the data.
Interesting. And so basically then when my SLO is breached, for example, I can look or use my observability tool and figure out, okay, where exactly it is the problem exists.
And yes, exactly. And that's how I got into observability. Is I came into observability from the SLO angle, where I was repeatedly asking Google Cloud customers, like, hey, why don't you adopt service level objectives? That alerting based off of when your SLO or when your error budget is about to be blown is so much less noisy than alerting on every kind of signal bubbling up from the bottom. And I consistently got pushback. And that pushback was, but if we get an alert that says something is wrong, how do we figure out what's going on? Right? And at the time, I didn't have a great answer for them because just be Google was not going to suffice, right? Sure. At Google, we had very meticulous logging and we had very meticulous high dimensionality, high cardinality metrics. And we had tracing, right? But I couldn't tell customers just do that, right? In order to be able to debug starting from the top and bisecting your way down until you find where the problem is. And then I discovered that people outside of Google, like Honeycomb and Lightstep at the time, like were offering observability as a service, or at least observability platforms and solutions as a service that people could then use. And then I realized that SLOs and observability complemented each other nicely because when your SLO starts being blown, that's when you turn to observability because something is wrong with your service is the classic unknown. Where having that tracing, having that ability to interpolate and bisect and figure out what's going on, that's what helps you resolve the SLO. And sure, hypothetically speaking, if you had 100 alerts firing all the time, one of them probably relates to a real problem. But how do you know which alert at the bottom is the answer? And there have been so many kind of ill-founded startups that are presuming this kind of bad foundation of, oh, we just have to slap some machine learning on kind of these lower level alerts. Like disk is 90.1% full or CPU is 75%. And it's just like, what if instead of using machine learning to harvest the sea of alerts, what if instead we had the ability to look at individual example failing traces that are causing my SLO to be blown and to be able to trace those through and figure out where is it broken? So that's, I think, how I got to this answer around SLOs and observability really enabling each other. That you can't really effectively track and measure and debug an SLO without having observability as a tool to be able to drill in.
Makes sense. You mentioned briefly about grouping similar, let's say, services or endpoints together. When you say similar, is it based on the implementation detail? What flow are they going through, or based on the user journey?
It can be a mixture. I think that when you're measuring a trustworthiness concern and trying to set similar guardrails, this page should load quickly because it's read-only. It should load in less than 250 milliseconds, right? That is a grouping by category of request. Even if along that user journey, you might have view the homepage, then run a search, then view a product, then add to cart, then check out, right? Like that might be that's a more complex user journey, but it has a number of steps, some of which require fast response targets, some of which are more tolerant to slowness, right? So that's one category is grouping it by what are the user's expectations around how quickly should it complete. The other category, as you're saying, is based off of common implementation, right? That every endpoint that's running through a service is likely to have similar failure outcomes. I'm going to take the classic consultant cop out here. I'm going to say it depends. It depends a lot upon how mature your SLO practices are, what kind of ownership you have, right? Because if each individual team owns its own collection of services, it's a lot better to set SLOs based off of what the collection of services is rather than based off of, because the team can be held accountable to it. Whereas if you have one centralized ops software operations center, then it might make better sense to take the full system view because there's not necessarily going to be one owner for one service.
Makes sense. Let's talk a little bit about, since let's say we have SLOs and every team is on the same page. We talk a little bit about the user journey, right? And when we say journey, it feels to me like there are like multiple steps involved and the user is reaching somewhere, but it could be just one step, like hitting an endpoint. So are there some other terms that we also use for some, let's say I am some, let's say, search or I don't know, cart team, and I use authorization service. I just make a call. So from the authorization service perspective, I am the user, right? So it's not
That's
really
correct.
a journey.
You're an internal user. Yep.
Exactly. So it's not really a journey, but it's more like a user call, for example. So do we use this terminology for internal SLOs as well?
Yes, we do. And I think this is nicely getting to us finally talking about, we've been talking about SLOs, service level objectives, for about 15 minutes, but we haven't talked yet about a service level indicator or an SLI, right? So the SLO states an objective on what we're trying to achieve, reliability percentage, some broad fluffy words about what the user is trying to do. An SLI, a service level indicator, is something that we can concretely use in an engineering sense, that it resolves to true or false, right? Like it resolves to this request is in scope or out of scope. This request, that assuming that it is in scope, is a successful request or an unsuccessful request, right? So in that context, it's very easy to say, in the context of the authorization service, a 403 is not necessarily a failure, right? That might be you returning that the credentials are invalid, right? So you have to define in the business context, how do I take this log entry or the structured log or this trace span and resolve it to true, false, or undefined, right? And then you can compose that SLO then in terms of all of the SLIs that are in scope, what percentage of them do we expect to succeed on an ongoing basis?
Okay, that makes sense. And when we talk about SLIs, I instantly think about the 4 golden signals written in the SRE book, right? So there's this availability, saturation, and traffic. I understand the first 2 from,
Yes, although I would argue you should just smush them together, right?
Okay.
Like it doesn't matter if it's 8H200 if it takes forever in a day.
Yeah, okay.
But yes. So yes, there's the success of the traffic. And I think you are right. The other points about saturation are really interesting as we've started to encounter the economic issues of the past year and a half, where suddenly people have to think about not just am I serving requests successfully, but massively over provisioning by 2x, 3x, 5x, but also am I doing so in a cost economical fashion that helps the business achieve its goals? If out of every dollar of goods sold, we're spending 10 cents or 20 cents on servers, that's probably not sustainable if you're an e-commerce business that depends on tight margins. So suddenly the saturation and utilization of your service starts to really matter a lot more. So I think that one's a little bit harder to lend SLOs and SLIs on to because it's not on a per transaction basis, unless you have very fine-grained metrics on what the cost per transaction is of your compute. If you can, that's great. But I think it's just even setting a baseline and saying we are aiming to have an objective of 65 or 75% server utilization, that we're shutting down servers when we don't use them, right? That we're optimizing, right? Like the other thing that I think is super deceptive is I've seen teams at Google, nameless teams at Google in the past when we had utilization code yellows, where they're setting an objective to make your servers 65% utilized. And they were like, fine, we will go ahead and run a process that just burns CPU in order to meet our target, right? Not just setting utilization targets, but also saying we are going to eliminate waste. It is okay if you undershoot your utilization target while you are trying something out that might be more efficient, right? So I think that you are correct that kind of saturation is an important thing to measure. I don't think yet that we have a robust and mature science around how to set SLIs around utilization.
That is really helpful. Thanks for answering that. And let's focus on the availability and the latency metric, or SLI, right? And so the SRE book also talks about how can you come up with an SLO for the first time, right? So you can look at the historical numbers and you can make a good judgment. Of course, it's not the final value. You have to keep
exactly rating. But it's an implicit SLO, right?
Yeah.
If your customers are used to a level of performance, that's probably a good starting point. And then if it's not good enough, you can crank it up over time, right? Yeah. This is the difference between an achievable and an aspirational SLO.
Absolutely. And so we tend to look at the P99s, for example, right? And so what is a good way to think about it? Should we keep focusing on P99s?
Okay. No. I think that, yes, obviously, and a P99 is much better than an average in terms of helping you identify outliers.
Yeah.
But what you actually want is the inverse quantile, right? Instead of saying, I expect the P99 to be less than 300 milliseconds, right? If your P99 exceeds 300 milliseconds, that means that an n-bounded percentage of your users might be experiencing latencies of 10 seconds or 20 seconds, right? So instead, it's a lot better to say, I expect n% of my user transactions to be better than 300 milliseconds, right? Instead of, I expect the P99 to be better than 300 milliseconds, right? So this nicely ties into the idea of having a request by request service level indicator and composing your SLOs of percentages of transactions that are fast enough and succeed, rather than saying, we know what the worst 1% is, but we can't bound how bad the worst 0.01% is, right? And instead, we just want to say, if it's slower than this cutoff, I don't care exactly how slow it is, right? I want to maximize, or at least keep within reason, sufficiently high range, the percentage of requests that are fast enough to meet expectations. Everyone else we're considering a fail, and they should refresh or they should do something else.
So how does that translate to setting up SLOs? Are you saying that you should look at the distribution or different levels of, let's say, P99?
More or
P50?
less, right? This is why I think that metrics are flawed, right? That kind of aggregate P99 metrics, right? Any competent metric system can give them to you, but they can't help you actually figure out which requests are slower than which requests are part of your 1% that are slower than the P99, right? Metric system doesn't help you with that. So I think it's much better to use traces, use structured logs and traces corresponding to real user requests, and then to run that rule evaluation on each request that comes in and say, is this in scope? Is this fast enough? If it's not fast enough, let's record that so that we can go and debug it and record the full trace and look at it. So that's basically why I'm such a huge champion for structured events, structured logging, distributed tracing, is because it's that kind of correct input into your SLO system, rather than saying we've got an SLO system being driven off of metrics, but all of the real debugging stuff lives in the logs or in the traces, right? Like, your observability system is in a lot of ways your primary store of how you can evaluate your SLIs if you choose to do so.
Awesome. Since we were talking about SLOs and SLIs, we've also covered some of the common mistakes people do when setting up SLOs. But I would still like to ask you, what are the
It's just overcomplexifying it, right? Like launching the big project to index and catalog all of the SLOs and to measure them all the way from the user's mobile device. And start somewhere, measure something, iterate, continuous improvement. It's fine. The other thing that I've seen people get wrong is people set an N-achievable SLO, right? They'll say, I want to have 6 nines of availability. And it's okay. I can certainly send you an alert saying that you're always violating your 6 nines. How does that actually help you? Are you really going to pause all of your releases when you fail to meet 6 nines? I hope you have a budget prepared that includes $6 billion to launch satellites into space to provide a mobile cell phone service. I actually was joking about that, but it turns out that in the past week, I've heard about Starlink actually launching direct satellite to cell phone service, which is cool. But again, that costs a lot of money. Yeah. If you want 6 nines of availability, your consumer cell phone service is only about 3.5 nines of availability, 4 nines if you're lucky. So good luck. So yes, unachievable and realistic targets. So either people overcomplexifying or setting unachievable targets. Those are the 2 ways I see people mess it up.
Makes sense. I have so many questions, to be honest, but in the interest of time, I would ask you, since we talked about observability-driven culture or observability-driven development culture, how should people start thinking about it? It's not like you have this culture or you don't, but it's a continuous process. So how should people start approaching, and where does it start?
I think it starts with every line of code that you add to your code base. I think it starts with your pull requests, right? Like, you would not accept a pull request that had no comments in a 500-line file, right? You would not accept a pull request that had no tests or that had no changes to tests if it were changing functionality. So why are we checking in code without adding trace spans, right? Like, why are we checking in code without adding attributes, right? Why are we checking in code that is printf debug log statements instead of structured attributes, right? So I think it basically revolves around, what standard do we accept as code reviewers? What standard do we accept as people who are submitting code for code review? Can we give people nudges? Can we add templates to pull requests that say, did you add tests? We don't even have a checkbox for did you add comments, but that one is implicitly there. But similarly, what's your observability plan, right? Link me to a query that I should expect to change as a result of this code being checked in. So we do this at Honeycomb, right? Like, there's part of our standard pull request template that says, what is your observability plan? And what is your deployment plan? And you should be able to fill in and paste in a link to a tool like Honeycomb, right? Because we dog food Honeycomb, right? So you should be able to paste in a link that demonstrates the before and after.
That makes sense. Cool. Liz, it was such a pleasure to talk to you and to ask all those questions around observability and reliability, which is so close to what I do every day. And I'm sure our viewers are going to get a lot of insights and great starting points to not overcomplicate stuff, but get started with observability and SLOs and all around a better development culture. So I thank you again for joining me today, and I hope to collaborate with you more in future on these topics.
Yeah, I would love that. Thank you so much.